Now we're going to solve exponential equations. And the way we did this before, the first thing we look for, can we do a common base? If we can do the same base on both sides, that will make it so much easier to solve. Otherwise, we're going to have to take the log on both sides. So let's start with number one. It says solve each of the following exponential equations. I notice we have a base 3 equal 81. So the question is, can I change 81 and rewrite it with a base 3? Yes, 81 is a 3 to the 4. So we fix this, we fix the same base equal sign. The rule says you take those powers and you set them equal to each other. We'll finish the algebra, and x is equal to 4 minus 1 is a 3. So once, if you can fix the base on both sides, it's easier to work with. You look at question 2. I have 2 to the x equal 5, 5 to the 1. Base 2, base 5. I can't really fix this 5 into a base 2. I can, but it's a long process. So in this case, when it's not as easy as this one, 81 as 3 to the 4. Now in this case, I have to take the log on both sides. In algebra, if you do one thing on one side, you have to do it on the other side. So look what happened. When we took the log on both sides, now I have a logarithmic equation. The power is x. Remember, if you have a power, you can bring it to the front. So that's x log of 2 equal log of 5. Since I'm solving for x, log of 2 is just a number. So I'm just going to divide through with the logarithm of 2. And there's my answer. X is equal to the log of 5 over the log of 2. And that's the answer, whatever that is. We can put that on the calculator and we can find that out. But that's how you do it. If you cannot fix the base, take the log on both sides, use the properties with logarithm. In this case, this power put in the front makes it easier to finish the algebra. Number 3, same question, solve the exponential equation. The base is 3 to the x here, the base is 3. Always look and see if you can divide, maybe add, subtract, and all that stuff. In this case, we can divide through with the 8. So that will make it look a little easier. The base is 3. I'm not going to be able to fix 5/8 into a base 3 easy. So I'm going to take the logarithm on both sides. Again, x is a power, but now it's log, so I'm going to bring it to the front. See how important that property of logarithm is? It's helping me bring the x to the front. Log of 3 is just a number, so I'll just divide through and I have my answer. I can put these numbers on the calculator, and that turns out to be negative 0.428. Same question for number 4. Again, I have a base 5, I have a base 3. I'm not going to be able to fix the base to be the same. So we're going to take the log on both sides. Anytime you have more than one term up here as a power, put it in parentheses, please. So our x is our powers, so now it's a logarithmic equation. So now I'm going to just bring the power down to the front, just like I did before. Okay? Remember, I'm trying to solve for x, so since I have more than one term here, I'm going to do the distributive property. So log of 5 times x is x log of 5 minus 2 log of 5. I'll do the distributive property on this side. That's a 3x log of 3 plus 2 log of 3. We're going to bring all the x's to one side, all the numbers to the other side, like we normally do when we do the algebra. So what I'm going to do, this has an x, so I'm going to subtract this to the other side. And since this is a number, I'm going to add this number to the other side. So this is what we're going to end up with. So I take this over, I brought this over. I have x log of 5 minus, I brought this over, the 3x log of 3 equal, I had the 2 log of 3, then this one I took over, so I added 2 log of 5. So I have all the x's on this side, but I have two terms, so I'm going to factor the x out, open parentheses, and write down what's left. And copy down this side. This side is all numbers. So now I have x times, this is just a number, just like we did before. If I have a number times x, I can divide through. So I'm going to end up with x equal to 2 log of 3 plus 2 log of 5 divided by this, log of 5 minus 3 log of 3. Now you can put this stuff on the calculator, make sure you use parentheses and all that stuff. And I ended up with a negative 3.212. Okay. Number 5. Again, so anytime, remember, if you can divide, add, subtract a number to help you make it easier, please do so. I notice I can divide by 500, so that would leave me e to the 0.3x is equal to, simplify it, it's 6 divided by 5. Base e, base 6, base 5, I can't fix it, so I'm going to take the log on both sides. Because I have an e, we're going to take the natural log, ln, on both sides. Again, I'm solving for x. X is a power, so I'll bring this one down. If you don't know it, you should remember this. The natural log of e, because this is base e of a base e to the 1, so that's a 1. So what I have here is a 0.3x equal natural log of 6/5. I'll finish it by division. So it's a natural log of 6 divided by 5 over 0.3. Now I can grab my calculator, and that turns out to be 0.608.